Yes, okay. We
Okay,
can
we're
start.
ready? Okay. Good evening, everyone. Oh. Good evening, everyone. Welcome to the evening portion of the 9th White Cane and Accessibility Festival of the Barrier-Free Access Association. Tonight, we're here to discuss a topic that has been often discussed in Turkey and in blind circles around the world. Can a blind person drive a car independently, and how? First, I would like to introduce my fellow moderator, Can Deniz Balkaya. Can Deniz, how are you? Can Deniz? Oh, we're not connecting to him.
Can you hear me now?
Yes, now I can hear you.
Oh, okay, that's good.
Sorry to interrupt, but I think I'm not an interpreter anymore. Something happened, I got disconnected. So can you again assign me as an interpreter so that I can go to the other
Sorry.
channels to start
And I
interpreting?
think Anil dropped off as well.
Yeah,
I'll do
I don't know
that.
what happened.
Sorry for delay. Sorry for the problem. Someone. Yes, now it's okay. Yes, sorry for the technical issue. I'm Can Deniz again. I'm a member of the No Barrier of the Free Association. And that's all from me. And continue to next guest.
Wonderful. And we have two guests tonight to discuss the issue of the Blind Driver Challenge project of the NFB with us. We have Anil Lewis, who is Executive Director for Blindness Initiatives for the National Federation of the Blind, and again from the NFB, non-visual accessibility analyst Carl Belanger. Both of you gentlemen, welcome. How are you? Carl, and I think Anil might be.
Hi.
Oh,
I'm
hello.
Carl Belanger. Yep. Can you hear me?
How are you?
Thank
Yes,
you.
we can.
Sorry about that. I think I'm on
okay.
now. Yeah. I
There you
don't know
go.
what happened. I got dropped just as soon as we went to stream. But yes, my name is Anil Lewis. I'm the Executive Director of Blindness Initiatives for the National Federation of the Blind. Pleased to be here. And Carl, you want to introduce yourself?
Sure. I'm Carl Belanger. I'm a non-visual accessibility analyst. Do a lot of things involving technology for the blind here at the National Federation of the Blind. Happy to be here as well.
Wonderful. And it's we're very happy to host you. So let's switch over to the topic of the Blind Driver Challenge. Now, most people, when they think of a blind person driving a car, they think of the autonomous cars that companies like Tesla and Google are trying to come up with. So that's not quite how the NFB envisions this topic. What was the inception of the Blind Driver Challenge? How did it begin? I believe in 2004, yes?
Yeah, conceptually, yes. And I can talk through the progression.
Yes.
And hopefully we can pivot to a discussion around autonomous vehicles as well, because I think that's important. But starting with the Blind Driver Challenge, our president at that time was Dr. Mark Maurer. And as an organization of blind people, we continue to set high expectations for blind people and continue to try to promote the capacity of blind people through society so they recognize we have value. So one of the questions that was posed was, what is it that society thinks blind people can't do? And we could get a whole list of things, but first and foremost, a lot of people would say drive, because driving is considered a visual activity. The windshield is what you need to be able to look through to see the road and the pedestrians in order to make good driving decisions. Well, we challenged that. Was it the vision that's necessary to drive? Or was it just the acquisition of the information about the environment that you need in order to drive safely? So we, as an organization of blind people, recognize that there's many ways to get access to information that are non-visual. So we set our sights on trying to create partnerships with universities who were forward-thinking, researchers and manufacturers who were forward-thinking. And our president now, Mark Riccobono, was the executive director of the Jernigan Institute at the time. And he was challenged with the responsibility of building these partnerships to prove that a blind person could actually drive a vehicle. So around 2009 and 2010 is when the rubber really started hitting the road, when we really started making progress. We found partners with Virginia Tech University, their whole robotics department there, led by Dennis Hong, were very much into autonomous vehicle manufacturing and research. And then a manufacturer of military-related autonomous technology was Torque Robotics. So the three of us, the National Federation of the Blind, Virginia Tech, and Torque Robotics, embarked on a research project to create non-visual interfaces that would allow a blind person to actually drive a car. Now, we have to admit that even in that beginning process, the universities and the manufacturers also didn't believe what we were really trying to do. They thought it was more of a gimmick. Torque Robotics says, well, we deal with autonomous vehicle technology. We can put a blind person in the car. We can program the car and it'll appear like the blind person's driving it. And we're like, no, that's not what we want. We want the blind person to be in control of the car and actually be able to crash it. Not that we want to crash the car, but if you're not able to crash it, then you're really not in control of it. So we tried a variety of different ways of getting access to that information. But before I go down that path, I think it's obvious to everyone that technology provides access to just so much information. So the problem wasn't how or what information we could get. It was what information out of all of the information that you can get from GPS systems and cameras and the LiDAR technology. You can't convey all that information. It's infinite. So what is the key? What are the key elements that a person needs to drive a vehicle? Well, you need to be able to control guidance so that you can stay in the lane if you're driving on the road. You have to be able to get information around what the appropriate speed is for different environments. So we focus primarily on those two aspects of giving the blind driver information about the environment. We focused on navigation, making sure that we can maintain the lane, and speed control. And of course, a host of those other factors are making sure that you can see obstacles and recognize their obstacles so that you can navigate around them. So we tried a host of different ways. We had, I don't know, well, I'm sure air hockey is universal, but the air hockey machines that blow air up to support a hockey puck that people can play hockey on the table by knocking the little disc back and forth. We use that to convey kind of tactile information through the air pressure that would simulate a map so that it could be virtual or dynamic. We didn't necessarily use that technology for the blind driver vehicle, but I do believe that technology is being used for some other ways of presenting information to blind individuals non-visually. And I could go down a host of other ideas that we incubated that didn't really take hold. But we resigned to use two different technologies that were developed. One was called the Drive Grip, which is a fingerless glove system that had motors on each of the knuckles, the four knuckles of your hand. And what would happen is as you're navigating the vehicle, the combination of the information being provided by the GPS and the LiDAR and the camera systems would tell you where the vehicle is in position to where it should be on the road. And if the vehicle needed to be further to the right in order to maintain the lane, then the knuckles on your right hand would vibrate 2 levels of extremity. So if you needed to turn right gradually, your pointer finger, the motor on your pointer finger would vibrate. If it was a more aggressive turn you needed to make, then it would go progressively to the middle finger, to the ring finger, to the little finger. So if it's vibrating all 4 knuckles, then that's probably a hard right turn. And what would happen is as you move towards center or where you needed to be, the vibrations would then go back, across and to the other side if you overcompensated. So what you wanted to do is kind of maintain a good vibration between your left and your right pointer fingers with that vibration, because truth be told, when a sighted person is driving, they're not holding the steering wheel static. They're continuing to make minor adjustments to maintain their position as well. So this was just a way of demonstrating that in a non-visual fashion, we can get information about those adjustments that needed to be made in order to maintain the lane. Worked really well. Of course, it wasn't something that you could just jump in the car, put on the gloves and do. You really had to understand it and practice it the same way you would if you were sighted. I mean, you don't just jump in the car and drive. Someone teaches you or you learn through trial and error, and that's what we had to do. And then the other technology we used was called the speed strip. And the speed strip was just a viral tactile seat cover that vibrated on your back and on your leg. And we use progression of vibration in this as well. So if the back vibrated slightly, then you needed to, oh wow, let me make sure I get this right. I think it was the seat that vibrated to tell you your speed, but the back would vibrate when you needed to actually stop. So as the vibration sensation moved further ahead, you could go faster. If it moved further back, you should slow down. And if it vibrated around the back, then you should stop. But again, just conveying the information. And that would be, say, to give an example of how both of these technologies work together. You're driving down the lane, and let's say there's a box in the middle of the road. So you're going to get sensations that, one, tell you that you need to turn either left or right, depending on where the box is positioned, to avoid the obstacle. So you're going to get the sensation in your hand that tell you to turn in one direction or the other. And again, it's like GPS. So if you chose to go to the left of the box, you could do that. And it would give you the vibrations to let you know a clear path moving back to your planned travel route. Or if you choose to go to the right of the box, it would give you the vibrations that you can navigate around the box until you got back to your true navigation path. And then also, as you're approaching that box, you may have been at a certain speed, but you will start getting the sensation from the speed strips to let you know you needed to slow down. And if you did not correct your trajectory, if you did not turn left or right to avoid the box, you would get the full vibration that would tell you that you needed to stop or you're going to hit the box. Mm-hmm. And as I said earlier, the reality is you could choose not to do either, and you're going to hit the box. And that's just going to prove to everyone that, yeah, the blind person was in control of the vehicle. They just made the bad decision.
But it was their responsibility.
Exactly. Okay. Exactly. And let me know how you want the flow to go. I have as much of a narrative as you want. But if there are specific questions as I move along, please feel free to interrupt. One of the things that we did to demonstrate the capacity is in 2011, in January of 2011, we put together a public demonstration that we did work collaboratively with these research partners to actually develop and hone these interfaces. So President Riccobono was actually able to take our vehicle, which was a Ford Escape. We chose a hybrid vehicle because the battery technology used to propel the hybrid vehicle was the same technology we used to support all of the other technologies, the GPS and the LiDAR, et cetera, for the vehicle. So that worked out really well. We went to the Daytona International Speedway, and President Riccobono, and there's a video if you'd like to see it at blinddriverchallenge.org. But President Riccobono drove the vehicle, and the first thing he did was go through a slalom, I believe. I forget the actual process of what we did, but one, He went through a slalom course, meaning going around and between different pylons. He went between two obstacles to make sure that the precise navigation was possible. One of the most dynamic pieces of what we did, he actually was following a big van. And we want to prove again that this was not programmed, that it wasn't someone running it with a joystick or whatever. So in that van, we had boxes, and we threw boxes out of the back of that van randomly. So there's no way to control where they landed. And President Riccobono had to navigate around those boxes wherever they fell. So he did that successfully. And then at the end of that particular piece, he actually sped up and passed by the van. Again, just trying to demonstrate and prove to everyone that he was in control of the vehicle and able to make these dynamic changes in how he operated in order to drive safely. So that was really kind of the run of show, but I'd like to speak more specifically in the context of the Blind Driver Challenge, the kind of positive externalities we gained from that particular research partnership. Is that okay?
Yes, but just a quick question. Now that we've
Please.
put a blind person behind the wheel,
Mhm.
when we tell people in Turkey, at least, that this has been happening, again, they think of the autonomous car first. And when we tell them, no, the blind person is in control, they're a little nervous, would that really be safe? What has the reaction been from blind people? I mean, we know sighted people have had some reservations in Virginia Tech, but when you tell blind people, whether it be in the NFB or outside the NFB, what has their reaction been?
Yeah. So, as blind people, we're not a monolith. We have diversity of opinions. We're really truly a subset of society. So you have blind people that are excited about this as an opportunity. You have blind people that think that we were crazy to even pursue it. And there are blind people throughout that spectrum, just like sighted people are. And I think that the hard part, excuse me, to talk about that and then go back to the positives, the hard part is getting people to believe that it's possible, right? So there's so many ways with the development of any technology that you can poke holes in it and see why it would not be successful, or what problems could be created. And we run into that all the time. And my canned response to that, because I love people that say stuff can't be done. And my canned response to that is, I love people that say things can't be done because they are the inspiration for those that prove that it can. So if you don't have people adamantly saying it can't be, you don't get those people who say, oh, yeah, I can. Yeah.
Now, have you been able to drive this pilot?
I got to drive the car as well. Both President Riccobono and I were trained in the vehicle. And during the demonstration, I was in the wings. We had another vehicle with the same technology. So if anything went wrong, then I was supposed to step in. So I'm glad things didn't go wrong because, that was a lot of pressure. And I have a great deal of respect for President Riccobono to be able to do what he did with everything on the line, because that was a significant investment. And if we would have failed, it would have probably done more damage than we probably could have controlled. But I'm just glad it was successful.
Wonderful. And this was not your first time behind the wheel, of course. You lost your vision at 25. So you were returning behind it, and it must have been an exciting experience.
Oh, absolutely. When I went blind, that was one of the hardest things, was to turn in my car keys. And I never thought I would drive again. But I was excited about the opportunity. And that's one of the things that we did learn. So President Riccobono has been blind all of his life. He had never really driven, not legally. So he may have driven with someone telling him to turn left, turn right. But we also had a kind of secondary hypothesis does a person who's driven before have a better ability to drive non-visually, or does the blind person who knows how to drive or navigate their environment non-visually have an advantage? And our informal research shows that neither was an impact. We felt that we were both fairly equal. I think President Riccobono was just better because his determination and this is just, it's unmatched. So yeah.
So
It
let's
was a
go
great
on.
experience.
Let's go on then with the narrative as it is.
Okay.
What's been happening?
So some of the things, well, I want to talk about some of the things we learned. So we went into this really not knowing whether we could do it, because a lot of people think that it was a gimmick. It wasn't. A lot of people think that it was just thrilling all the way, and it really was a research project. And in the beginning, we spent much more time off the road than on the road because the technology really was developed, and we tweaked it and we got better at it, and we all grew with respect to our knowledge and participation. And to your question around society's perception of it, that was always an underlying piece. So it added a whole different dynamic with respect to what we were doing. It wasn't just necessarily curiosity. We were faced with a lot of public opinion around the efficacy of a blind person driving a vehicle. And I have to admit that, our goal wasn't purely to create a vehicle, that blind people would actually drive on a road, just right along their side of peers. Our overall goal was to gain respect in the industry, right? Find some really forward-thinking partners that could help us develop that next generation of innovative technology so that we can fully participate in society because we knew the autonomous vehicle was on the horizon. And our fear was, and it was true in the beginning, because, Google was developing autonomous vehicles around that time. And we really wanted to work with them to make sure that as they develop this technology, that it would be accessible. But just like everything else that people do related to blindness, they say, well, we'll fix it for you. And we know from our history that when we allow people to do things for us, even though they're well-intended, they do things in a way that aren't authentic to what we need them to be. They develop from a custodialistic kind of caretaker mentality. And again, we want control, we want autonomy. So we weren't able to break through that. So that's one of the reasons that we engaged in this too. And as a result, we have a tremendous degree of respect from not only autonomous vehicle manufacturers in the mainstream like Ford and GM and VW, the autonomous technology manufacturers like Waymo and Cruise, the autonomous vehicle researchers in a host of universities here in the United States. They see us as a viable resource with our lived experience and expertise that's going to help them develop autonomous vehicles that blind people can access equally as the sighted. And the thing that they've recognized is even beyond that is their return on investment is not that they're creating a vehicle that blind people can use, but a vehicle that's better for everyone to use. So years ago, we hosted a summit of all of the autonomous vehicle, the manufacturers and the technology developers, et cetera. And they came here and they kept asking the question, if we create an accessible vehicle, how many more will we be able to sell? How many blind people out there are going to be able to afford these vehicles? Well, the answer is not a lot. I mean, because of all the socioeconomic challenges we face based on society's lack of belief in our capacity, we're not able to get as many blind people gainfully employed, generating the revenue that are required to pay these vehicles. And in all truth, these vehicles are going to be pretty expensive, so that, only the wealthy are probably really going to be able to purchase them. So we had to correct them. We said, one, back to my statement, they were saying it can't be done. And I said, well, again, glad that there are people that say it can't, because it's going to inspire those that prove that it can. And you shouldn't be asking how many blind people are going to be able to purchase it. You should be asking how much better is this going to make your vehicle in the market? If your desire is to sell vehicles, a vehicle that's accessible to blind individuals, and we extend that to other people with disabilities as well, is going to be the best vehicle in the class. Because transportation is not just for those that are able-bodied. Transportation is a necessary piece for people with all kinds of disabilities. And then the external point, the extra point of that is, just because someone is not disabled at this particular time doesn't mean that they won't acquire a disability. So again, your vehicle, which is accessible to a sighted person, but is also going to be usable by a blind person, which is also going to be usable by a person who has to use a wheelchair, is also going to be beneficial to that sighted person that may lose their vision for some reason, or that sighted person that even if it's just for a temporary time has to use a wheelchair to get around. That's going to make your vehicle the best. So that's the question you need to ask. That's your return on investment. And we were surprised that it really resonated. So our relationships with Waymo and Cruise and GM and Ford and VW have all been based on them recognizing that we have the lived experience and expertise to help them build the best vehicle in the market.
Wonderful. Now, there was another event you had with Dan Parker breaking
Yes.
the speed limit. That car used sound auditory feedback instead of haptic feedback. Am I mistaken?
Yes, that's correct.
So how does that work? Do you know?
Yeah. So
I'm not
Dan
sure.
Parker is an amazing man.
Mhm.
You know, there are people out there, you know, blind people that want to climb Mount Everest and blind people that want to drive cars. I'm not one of those blind people, but thank God for those blind people, because they continue to push the envelope to really demonstrate to society that given the right opportunity, blind people can do things that, you know, society just didn't think that they could. So Dan has come to us, has broken several speed records on a motorcycle, et cetera. And he came to us and he says, you know, there is an actual Guinness Book of World Records record for the fastest car, the fastest speed achieved while driving a car blindfolded. And I like this record because it's not just a blind record, right? If a sighted person wants to try to break this record, all they have to do is put on a blindfold and go for it. I would love to see that happen. That would be pretty interesting to see a sighted person do that. But Dan says, yeah, I'm going to do it. And the beauty of it is, so Dan is not just the driver, but Dan designed his technology, not just even the access technology, the whole car. We interviewed members of his team, and they were talking about how he had developed and designed and built, because he's also a machinist, an underlying carriage for the car that reduced the friction that allowed it to not only reach greater speeds, but also make sure that it maintained integrity with the road, because these cars go fast. They could very easily go airborne. And he also designed and developed and built, I don't know what it's called, but it's the little foil on the back of the car, again, to make sure that the front stays down and doesn't go up. And he also worked with his friends to develop the technologies that allowed him to maintain the direction. Because again, it's not, you don't just hold the steering wheel in one position and you go straight. It's constant navigation and maneuvering. So his was auditory. So the thing that was very interesting for me is when you hear his car and you think of cars that go this fast, you think of them as being very loud. His engine runs very smoothly. And he says he had to mindfully design an engine that was as powerful as those loud engines, but did not make as much noise, because if it made a lot of noise, it would interfere with his ability to hear the audio information that he was getting. He wore a helmet that also did some noise canceling. And essentially what it did was it would give him tones that would make sure that he would alter his trajectory in a way that made sure he maintained the lane to achieve the maximum speed. Because if he starts wobbling, not only would that slow him down and make it impossible for him to meet the record, it could also result in a crash, because again, you're traveling at some very high speed. So that also took a lot of practice, not only in interpreting the information, but continuing to tweak the design of his access technology so that he got the information as quickly as he needed it to make whatever adjustments and as smoothly as he needed, so that it wouldn't be jerky corrections that he was making. So he's a phenomenal man, not just fearless with respect to driving, but a phenomenal engineer, which also we interviewed members of his team. So he had engineers and machinists and mechanics all on his team. All of them had a great deal of respect for his knowledge and his ability. And, you know, I was thinking, to be honest with you, I thought, well, that's nice. They got Dan driving, but surely this team is the one that's putting all these pieces together. But no, once I got a chance to talk with them and interact with them, he was leading that team. He was the one that was giving them that direction. And interestingly enough, when we were actually going for the record over in El Paso, over in the spaceport, he had to, in order to break the record, he had to make 2 passes, going one to break the record and then going back in the other direction to break the record, so that the average of both of those speeds had to be higher than the existing record. So he made the first pass and he broke the record. Of course, he has to go back within, I think, an hour and do it again in order to make sure that he actually breaks the record proper. But something went wrong with the vehicle. And he wasn't able to make the second pass, or he chose not to because he felt that it would create more damage than he could repair. And he and his team stayed up to the wee hours of the night to come up with a different solution to make sure that they could, I forget what it was something with the transmission that would not let it operate in the lower gear. So eventually what they had to do the next day was they actually ran and pushed the car to get it started. But although that worked, Dan continued to work on the modification, and he was able to tweak it so that the car worked as it was supposed to and designed to. And the next day, which was our last day, at that we had access to the spaceport, it was getting kind of nerve-wracking. It was coming down to the last hour. He did it, and it was just so exciting. It was thrilling to be there. I count being at our Blind Driver Challenge demonstration in January of 2011 and being at the spaceport this past opportunity as 2 key pivotal experiences that I've had as a member of the National Federation of the Blind that really speak to our desire to challenge society's perceptions of our capacity and prove to the world that we have value, we have a lived experience, we have expertise, and we can work as a member of humanity to make this world a better place.
Absolutely wonderful. Now, before I get to the thing that really excites me now, you say about Dan Parker, we have 2 different cars using 2 different approaches to enabling a blind person to drive the car independently. That's very exciting news. So more proof than any that, we can do it. Before I get to the future implications of this, I just want to touch a little bit about the process of cooperation. Sometimes it can be a little difficult in terms of design for sighted people to get over some design ideas to us, or for us to get concept over to us in a visual manner, because we're both used to using different modes of communication, one visual, one non-visual. Were there any difficulties in that regard when you were working with Virginia Tech?
Yes. And again, they come into it with a lack of understanding that we actually have expertise and value and a lived experience that can help them develop it. They went into it with what I was talking about earlier, very custodialistic, we'll design it, we'll put a blind person in it, and voila. So it took a lot of negotiation in the beginning. One of the things that is important for us to gain the respect that we needed to be equal partners is we have to be very direct in our interaction with them. And again, at that particular point, Mark Maurer is our president, and if anyone knows him, they know that he's a no-nonsense guy when he needs to be a no-nonsense guy. And we were able to get them to at least make sure that they listen to us, because again, we were funding this project. So they had to do what we wanted them to do. And as we progressed through it, and they would tell us, well, we're having a problem with this. And then we would come to them with innovative ideas on how to address that problem. We slowly got to a place where they were like, oh, wow, you guys really do know what you're doing. And if when you reach that space, then you can start working collaboratively as a team. But the other piece that's important is sometimes we go into these partnerships and we think that we possess all of the expertise and we want everybody to do exactly what we say. But no, there's sometimes when, of course, the Torque Robotics guys or the Virginia Tech guys had a very valid point or a very valid solution. And we have to be open-minded enough to make sure that we are equally open to the suggestions that they have if we want to get to a real solution. And then the overall goal has to be understood at one point that you want to develop a multimodal means of getting something done. So it wasn't just a matter of us developing a car that could solely be driven by blind people, because if we were moving toward a place where we were trying to get blind people on the roads, then those cars would be less likely to be adopted if a sighted person wasn't able to drive them as well. So it has to be a consensus understanding that we want to build. We want to build a vehicle that has a multimodal interface that benefits everyone.
Sighted and blind can drive it, and that I think brings us quite quickly before we get to Q&A to the future. Autonomous cars, of course, are growing. I mean, the project is being developed. They haven't been on the road independently yet, at least I think only in California.
Yeah, they're in Arizona, California, some in Florida. Yeah, there's several locations that the cars are out there, and some of them actually without drivers. Yeah.
So this technology that you're planning isn't meant to be its own independent, but it's meant to affect the evolution of cars. What do you see for the future for blind people, both in the US and in Turkey? What doors will this open? What will happen?
I think that realistically, again, now that we've validated our expertise in this space and are working collaboratively with the autonomous vehicle manufacturers and the researchers and et cetera, that we are in that same mainstream of development of autonomous vehicle technology that society is going to be using in a real robust way. It's going to really break down some transportation barriers that exist now. So yeah, will there be autonomous vehicles that individuals purchase? Yeah, but only very wealthy individuals. The autonomous vehicle technology that's being developed now is really going to be distributed in more of a fleet model solution. So look at your Ubers and your Lyfts of the world and imagine that service being provided without the Uber or Lyft driver. So you still get on your app, you order a ride, and that vehicle shows up. There's nobody in the car but you and whoever you are riding with. So it's going to eliminate a lot of issues, excuse me, that we face now. But because of it, it's going to really result in, well, this is what's being promoted. And I'll be at an autonomous vehicle presentation in Pittsburgh next week on Wednesday. And what we're talking about is the environmental and socioeconomic benefits of autonomous vehicle technology. When you move to a fleet model that's not dependent on a lot of the overhead that exists now through our ride sharing options, you're able to provide an even more affordable ride. I love the fact that Uber and Lyft came because it cut my taxi ride costs probably in half, if not more. Imagine what more cost savings I'll get, you know, with the technology being implemented as a solution to reduce the overhead even further. So that's one thing. Autonomous vehicle technology being implemented in the fleet style gives opportunities to individuals who otherwise would have to only use public transportation to get access to more spaces than ever, because the person who uses public transportation can only go where there is public transportation. But with an autonomous vehicle, you're able to program a destination that's anywhere in a reasonable space. The socioeconomic implications also, I've seen instances where some Uber and Lyft drivers refuse to go into certain areas. We call them transportation deserts. I don't think an autonomous vehicle is going to be afraid to go in some neighborhoods, and hopefully with that access to transportation, they can have an increased quality of life that allows them to live better as well. The environmental implications, I talked about how most of this technology is being used in the electronic vehicles. So currently we're looking at the electronic vehicles really reducing the carbon emissions problem that we have with the pollution. So many benefits. And again, with our input during this design and development phase, as society benefits from the integration of autonomous vehicle technology, we as blind people will also be able to receive the same benefit.
Thank you very much. That I think answers one other question that I was about to have. I was going to ask, for example, with this car, you can get around obstacles and things, but you would not be able to notice, say, traffic lights or read speed limits. But when the autonomous car technology comes and is fused with this type of technology, now the car will know that a certain area has a certain limit, or through the links that it has with the system, it'll know that the light is red and things like that. So that would be probably be a wonderful innovation.
Yeah, and it's important to understand that the autonomous vehicles are not being developed just in the vacuum. they're being developed
Yes.
in an
With-
infrastructural model where
Mhm.
we're dealing with sidewalks and traffic lights. And so these vehicles are not only going to be able to scan 365 degrees around them, they're
Mhm.
going to be able to talk to the other vehicles. So they'll know that a car, you know, up ahead, way beyond where someone could see, has actually stopped. So they'll be able to brake, you know, before they end up with a rear end collision. They'll know that the light is going to be turning green before they even get close to the light, or red before they even get close to the light. Just adopting a lot of the infrastructural changes will also allow it. So there's a lot of that V2V technology where the vehicles talk to each other,
Yeah. Mhm.
and V2X where they talk to other infrastructural pieces. So it's just going to be a win-win.
Great. And blind people are now influencing that development. I think we won't have much more time, so maybe it's a good idea to switch over to question and answer.
Okay.
London's.
Oops.
And
Sorry,
yes.
can you see clearly?
I can hear you. We can hear you, yes.
Can you hear me?
Yes,
Yes.
we can.
Oh, okay, that's good. Okay. That was a good conversation. Thanks you again. And the first question from the Ayça. And I allow to her. Yes, Ayça, you can speak now.
Merhaba.
Devam.
Hello, merhaba.
Gökhan Güngör, ben Ayça ile beraber izliyoruz. Oradan soru soracağım.
Hı hı.
Mhm.
Ee,
We
benim
will
sorum
translate that.
şöyle. Benim sorum şöyle. Bu uygulama güzel bir uygulama ve heyecanlandırıyor ama herkesin bir araba yapıp herkörün deneyimleme şansı yok şimdilik. Bunu bir simülasyon aracı yapıp hem de mesela yarış oyunlarında hani herkesin oynadığı, görenlerin de oynadığı yarış oyunlarına da bağlanıp orada görenlerle aynı koşullarda yarışabileceğimiz ve o titreşimle arabayı kullanmayı yönlendirebileceğimiz bir şey deneyimleyip hem de bunu geliştirme şansları oldu mu? Hem de böyle bir şey geliştirildiğinde belki projeye de bir katkısı olurdu. Projenin daha iyi şeylere ulaşması için de bir kazanç getirme hem de insanların psikolojik olarak da simülasyonda da deneyerek daha kabul edebilecekleri bir aşamayı da
Hı hı.
aşmak açısından da yararlı olabilirdi diye düşünüyorum. Böyle bir uygulama var mı Amerika'da? Yapıldı mı bu çalışmalardan yararlanmalı?
So Gökhan Güngör, who is a member of ours, has a very interesting question. In order for people to get some better idea of how this process runs and what the technology is like, has the NFP or anyone else in the United States thought of creating a simulator? There are race car simulators for sighted people, and I mean, it's difficult for most people to get their hands on an actual prototype or come to a place or build their own prototype of a car that does this kind of thing. Would the idea of being a simulator, of creating a simulator that would give people some idea of how this technology would work, that would spread awareness of it, and that perhaps might enable people to understand, has this been something that anyone in the US has considered that you know of?
During our blind driver challenge back in 2010, 2011, when we actually did the public demonstration, we actually did develop a simulator so that people could sit and put on the drive grips and sit in the chair that had the speed strips, and I had the little arcade steering wheel, you know, so it gave the same vibration and the individual was able to control the car. Of course, we didn't continue that once we pivoted our blind driver challenge efforts to working on autonomous vehicle technology. So that particular simulator is probably obsolete at this particular time. But related to the autonomous vehicle technology, a lot of the manufacturers like Waymo, Cruise, they are currently now offering individuals opportunities to actually ride in the vehicles so that they can get that feedback. We were doing this as early as 2019. I remember in Las Vegas, we actually rode in some of the preliminary autonomous vehicle technology. Of course, at that time, they had drivers in the cars. They didn't control the car, the steering wheel, they were just there as a safety precaution. Now we actually have vehicles with no drivers out on the road, and hopefully sometime in November or December, I'll be traveling to San Francisco and taking a ride in both the Waymo and the Cruise vehicle. So I got to believe, and I'll check and follow up with you, that they're probably doing similar experiences around the world. So I'll see if and investigate whether they're doing any of that in Turkey as well. So it's not even about simulators now. You're actually in the actual vehicle.
Now, are any of these, or the way you've planned this project, will these autonomous vehicles be giving us feedback tactily and haptically? Are they doing this right now, or will they be doing this in the future?
Mm-hmm. And that's some of the feedback that we've been given, and Carl may want to speak to some of the examples that we've given around it. But yes, we are talking about how an individual who's blind in one of the autonomous vehicles will be able to get access to a variety of different information. Our big key is to try to make sure that the blind passenger has an ability to customize that feedback or that information, right? Because some people may want all the information. They want to know every building they're passing, every street they're crossing. But there are other people who say, no, I only want to have progressive information that lets me know I'm on the right path to my destination. Some people want to control the music. Some people want to, so yeah, we're making sure that the car is able to give information as well.
John Dennis, how much time do we have?
Thank
Thank you very much.
And another question comes from the Mikael Canun. Mikael, you can speak.
Merhabalar.
Merhaba.
Merhaba.
Sesim geliyor mu acaba?
Evet,
Evet.
geliyor.
Mikael, soru sorabilirsin şu anda.
Bizim geliyor mu sesimiz? Sesimiz gelmiyor galiba.
Mikael, you can...
Sesim geliyor mu hocam?
Bizim
Evet,
senin
yes.
geliyor da
Şu an geliyor.
bizimki
Alo.
sana gelmiyor galiba. Bizi
Alo.
duyamıyor galiba.
Faruk. Sesinin geldiğini ve soru sorabileceğini söyleyebilir misin? Muhtemelen biz arka plandayken duymuyor.
Hocam
Evet.
çok pardon. Ben duymadığım için karşı tarafı. Hocam merhabalar öncelikle. Benim size 3 adet sorum olacak. Şimdi bu bahsetmiş olduğunuz araçlar yani bu teknolojiler elbette güzel. Hani bunun ilerleyen yıllarda daha modern, daha güzel halleri çıkacaktır ama ya benim kafama takılan şey şu oldu. Şimdi mesela diyelim ki bir arabayla yolculuk yapıyorsun. Şimdi karşına atıyorum mesela büyük bir otobüs çıktı. Sen bunu nasıl algılayacaksın? Şimdi bunun sadece titreşimlerle bunu algılamak biraz zor olmaz mı? Bir de bu araçlar yani ne zaman pazara sunulur, ne zaman gelir? Bunu soracaktım. Bir de ben detaylı bilgi için NFB ile iletişime geçmek istiyorum. Bunu nasıl yapabilirim?
Ben sorunun iki bölümünü ben Gerçi Faruk beni duymuyorlar değil mi?
Yok, Faruk seni duyabiliyor. Sen söylersen Faruk muhtemelen tekrarlar onu.
Sorunun 2 bölümünü ben çabucak cevaplayabilirim. NFB kendisi bu arabayı satmayacak. O sebeple onlarla iletişim kurma meselesi yani gereği yok. Amaçları otonom araba teknolojisini etkilemek. Yani Tesla'nın ve diğer şirketlerin çıkarabileceği otonom teknolojiyi etkilemek yani. Kendileri bir araba çıkarıp satmayacaklar. Onun için gelecekte olan arabalar teknolojilerine Tesla gibi diğer şirketlerin arabalarına bu teknolojiyi sokmak amaçları. But there is one question, couple of questions that one of our guests asked.
Okay.
I was able to answer one of them, but one of them actually did interest me as well. Avoiding obstacles like boxes is one thing, but what about avoiding a moving vehicle or something a bit more dynamic? Is this really possible with this technology?
Yes. So
Yes,
in
go
the
on.
I'm sorry.
Sorry, go on.
Okay.
Yes.
In the blind driver challenge video, you'll see President Komodo actually does drive around the truck that was throwing the boxes. But yeah, I think that two things are important here. One is usually when people are asking this question, a lot of people are hypothesizing. Like I used to hear a lot of, well, what if the blind driver is approaching a young kid that's running out between two parked cars chasing the ball, that whole scenario. And they make it sound like that if they could see that, then that would not be a problem. But that's really one of the things that, we try to warn our kids about, because that's where a lot of things happen. So a lot of those dynamic obstacle avoidance things that they try to point out that would be detrimental to a blind person or an autonomous vehicle are the same ones that are dangerous for sighted people. So I always try to make sure that we draw those comparisons to make sure we're comparing apples to apples. And then two, the honest answer around that is people who drive as sighted individuals, they've been seeing all their lives. So they develop an innate ability to respond and react to different visual stimuli. That's not truly the case with blind individuals. So again, as I said, it's not going to be like I can get in that car and just be able to use that technology to be as dynamic, as someone who can see. But over time, if I had the ability to progress, learn and grow, practice, then it will be more compatible. And this speaks to what we're doing in other ways. We're trying to make sure that our blind youth, as they're going through the school systems, are being encouraged to use more non-visual means of accessing information. Right now, we're doing a lot of work around interpreting tactile graphics, because, excuse me, we can make representation of something tactily, but that doesn't mean that the student's going to be able to access the information because they haven't been taught how to use it. It's just like giving a sighted kid for the first time in their life a map of the United States. You wouldn't assume that, okay, here it is, I'm giving you this map, you should be able to interpret it. But we set that bar for blind kids when we enter that technology. So we have to make sure that we augment what we're talking about here with the development of the technology that can be used with the progressive training that everyone else gets toward being able to use that technology. So the short answer to the question is I believe that with practice, and the tweaking of the technology, that dynamic decisions around obstacle avoidance will be possible.
Okay, great. And we do have one more question from Engin Yilmaz, I believe.
Yes.
Thank you for that
Inari,
answer,
you
by the
can
way.
speak. Yes.
Hello,
you can.
can you hear me?
Yes,
Yes.
we can.
Yes.
You won't be able to hear us though.
Hello, this is Engin from Turkey. Actually, we chatted to you in 2011 in Blind Driver Challenge, and it was very good to see you again in this meeting.
Yes.
And my question is, actually, I am wondering that why did you stop developing the Blind Driver Challenge issue in 2011? Like you said in the topic that you said that, yeah, we should control the car. So not the car take us, we should take the car and we should control it. But in autonomous car, you know, we will enter the program, we will enter the destination, and the car will take us to the place where we want to go. Okay, this is also great, but this is, I think, contrast to what you said in 2011. So why did you stop such kind of development, and why can't we control the new cars? And secondly, as it comes to Dan Park's record, yeah, it was a very good speed record, but is the Dan Park's study is a general one or is a very specific individual car accommodation? So what I wonder is, for example, you told us about Ford and other many car manufacturers which developed autonomous cars, and you said that they are very pleased to listen to us and they listen our recommendation very good. But I wonder that what kind of accessibility and accessibility works they did about you. What kind of features, for example, are there in new autonomous car other than Dan Park's individual's effort? Thank you.
Well, thank you. I love the real question, so I'll take them in turn. In 2011, when we did the Blind Driver Challenge, and I think that the literature is still there, again, it wasn't necessarily to create a car that blind people could drive, but to create technology that would provide information to the blind driver so that they can make driving decisions. And we successfully did that. The overall goal was to gain respect within the industry, which we did that as well, to develop collaborative partnerships, which was also successful, and also hopefully be the jumping off point for the development of other non-visual technology in other spaces, not just driving. And we've also been successful in doing that as well. So we stopped doing it because it's really just a resource issue, right? So we had a choice. With the landscape of autonomous vehicles on the horizon and our existing effort to create the non-visual access technology, do we continue to invest our resources to continue to build technologies exclusive to giving blind drivers information to control the vehicle? Or do we get ahead of the game and get on the launching pad for the development and the design of these autonomous vehicles technologies? And all the signs have showed and continue to demonstrate that AV technology is going to be transformative for everybody. So the decision is simple. Do we create or use our resources to create a niche opportunity for blind people, or do we use our resources to make sure that we're able to participate in the mainstream innovative design and development of that next generation of disruptive technology? And we chose to be engaged fully in the mainstream development of autonomous vehicle technology. And again, because of our work with the Blind Driver Challenge, we came to this conversation with a demonstrated expertise in developing AV. Related to Dan's, Dan was really kind of making sure that we maintain our place in that perception, right? Because the biggest problem facing autonomous vehicles now is not the design of the autonomous vehicle, it's the public opinion. So we have to continue to make sure we demonstrate to society that blind people have some pretty good ideas of, what can be done in a way to make us, to demonstrate that we have valuable capacity. So that's really what that was about. We claim that record in a way that we can continue to promote to society that here you are, you've written off blind people, but here's a blind guy that's developed, designed, built a car that has broken a world's record. So that was really the onus there. And then the last piece is, you're right. We did want to make sure that blind people could control the vehicle. But looking at the development of autonomous vehicle technology, how are sighted people going to control the vehicle? They're going to be ordering the vehicle. They're going to be controlling with an app. They're going to be programming in a destination, and they're going to be sitting in the car. And guess what? That's the same way we're going to be controlling the vehicle. We're going to be controlling the vehicle the same way the sighted people are. finally at a place of parity, finally actually using the technology that everybody else is using, made it accessible in a non-visual fashion so that we don't have to ask for any more assistance than anybody else, and we can gain access to the same systems and access to the same destinations using the same technology as everybody else. But thank you. Those were really good questions. I appreciate it.
Thank you very much. That was absolutely wonderful. We called both of you and we thought we might be taking a bit more time, but we are a little, or rather our interpreter is a little stretched for time. So maybe one last question. Are there any questions? Candice?
For now, there's no question. If you want, we can pass the next guest. Oh, that's question Cam.
One more question, yes.
But Gökhan and Ayşe Güngör, this is second question for you. There are two questions, or there are two comments from the Engin and Ayça again. Is it? Yes, Ayça, you can speak.
Şöyleydi, sorumun ikinci kısmını tekrarlamak istiyorum. Hani bu simülasyonlar bir oyuna çevrilerek tamam, bekliyorum. Duyuyor musun Can Deniz?
Evet, duyuyoruz.
Tamam.
Biz duyuyoruz.
Sorumun ikinci kısmını aslında kaynak sorununa da değinmişken orayı tekrarlamak istiyorum ben. Bu simülasyon aracı oyuna çevrilip bilgisayar oyunlarına çevrilip bilgisayar oyunlarında körler yarışarak bir kaynak sağlanamaz mıydı projeye? Orayı özellikle sormak istiyorum.
Okay.
Yani belli ki o teknolojiyi genel olarak buldukları için artık yani farklı bir şeye geçtiler. Farklı bir kulvara. Ama sorabilirim isterseniz.
Sorsan olur.
They were wondering, I think it's more a question of why the driver challenge itself has been or rather why you've gone to a different path. Would it not have been possible to provide extra funding for the project by creating some simulators for blind people to use? And I do wonder if perhaps, I mean, now you can use, now there are actual cars that you can go and use, but I wonder if, well, let's answer that question about simulators, yes.
So, I mean, that's a very good point. I have a friend of mine who says that given enough time and or enough money, he can solve any world problem. But that's the key, right? We don't have endless amounts of money, and we don't have endless amounts of time. We could have dedicated time and energy to try to create a revenue model that would generate more funds to help support our blind driver efforts. But as the nationwide organization of blind people across the country, we have a host of different projects and programs that we need to simultaneously support. So we can't redirect so much of our resources in one direction without sacrificing using those funds for others. So I appreciate developing simulators and turning that to a revenue generating, but then that also means that we have to create a business infrastructure that, you know, handle the sales of the simulators and the repair of the simulators and provide training on the simulators. And that would have taken us away from making sure that blind kids get Braille in school and blind adults get access technology that allows them to work. So it is a trade-off. So with that particular crossroad, the question was, which way do we go? Not how do we try to support both, because that then takes a lot of other energy away from other programs if we were going to go down both paths. I hope that makes sense.
Yes, And I think we will have one last question then. Thank you very much, though.
Yes. Last question again from Engin. You can speak now.
Okay, now Sevda will have a question, not me. Okay, Sevda.
Yeah, okay.
Hello, everyone.
Hello.
Hello. Thank you for the fantastic presentation. I'm very happy to be here and to hear your voice, Ali and Can Deniz. Thank you.
Thank you.
I'm
Thank you
so
again.
happy. So I have actually two questions. The first one was, Anil, can you please draw a picture for the future projection? I mean, for example, there is a drastic development in technology, artificial intelligence technology. What kind of influences will be waiting on this issue? And actually, my imagine is to use my car in intensive traffic. Okay, so can you see some kind of thing?
Chance.
Yeah, do you see some kind of opportunity in the future?
So I think if I understand your question correctly, you want to know what's on the
So
horizon beyond.
I have. Okay, actually, I have two questions.
Okay.
The first one is, you know that there is a drastic development in artificial intelligence technology.
Yeah.
Do you think that it will affect also the car project? The first one. The second one is actually my imagine is to use my car in intensive traffic. Could you please tell me that if we will use our car globally in intensive traffic by using our abilities actually to participating as a decision maker?
Well, let me try to answer the second question first. So believe it or not, autonomous vehicle technology is probably going to be better served for navigating in high traffic areas because many of the accidents are caused due to the impatience of the human driver jetting in and out of lanes, being distracted doing something when they should be focused on the road. And the autonomous vehicle technology, of course, as I said, the vehicles will be able to talk to one another. So they'll be able to see where the surges are, see where the flow goes, and make really good decisions. So in some instances, although we want to make sure that blind people can control the car, sometimes the best way for you to control something is to let something that's smarter do it for you. So, you know, that's also a level of control, right? Yielding control is also control. The other piece about AI, and Carl again may have more or broader context. So artificial intelligence is being used, you know, in a very dynamic way in the development of autonomous vehicle technology. But just like with any other innovation, right? Everything that's developed that's helping in this autonomous vehicle space is not just exclusive to autonomous vehicles. There's probably going to be technology innovations in the development of these vehicles that are going to help robotics in manufacturing environments. So the artificial intelligence that's being used to make it possible for cars to navigate the roads will make it possible for robots to navigate more complicated environments. It may end up being used as technology that could help us with our first responders. So it's not even about having an ability to have a person picked up. It may be an autonomous way that a fire vehicle is able to go into a more dangerous situation where it wouldn't put firemen's lives at risk. So yeah, I think on the horizon, artificial intelligence is really only at its infancy. the more we get the machine learning in place, and then the more way we look at using this technology in really even in some of the more simplest functions, will be what creates a sea change in the development of that next generation of disruptive tech. Carl, I don't know if you had anything you wanted to add around artificial intelligence.
Let's have some final remarks on artificial intelligence and general final remarks from Carl. We haven't been able to let you speak, unfortunately. I'm sorry.
Go ahead.
We expected this actually to be much longer, but
Right.
we're going to have to end soon. So let's have some remarks from Carl about artificial intelligence and generally, and then I think we can end the event.
Okay.
Sure, certainly. I mean, artificial intelligence, as it is being developed, as Anil said, it's very much in its infancy, and what it's going to look like as it moves forward, how it's going to work is, still in many ways unknown. I think it's going to be a lot of different areas. Anil mentioned, robotics and other things. There are going to be a lot of interchangeability between and interworking things between, vehicles, because they're also talking about, autonomous delivery vehicles and robots, drones, all those different services, and they will all need to talk to each other. So you could have your autonomous car that you're riding in, communicating with and, working out a positioning with an autonomous truck that's making a delivery to a store. So these are all things that are going to come. And I think as this machine learning and things come, it's going to be very interesting in many different areas. People are working on camera-based object recognition and obstacle detection, which could have interesting implications when the technology gets there, and just many different areas where there's a lot of exciting things in the near future for technology, for the blind and otherwise.
Yeah. And the benefit of that is, again, we have this opportunity to make sure that we're working in parallel and not waiting until something's done to make it accessible to blind people and then waiting for that thing, which is separate than everyone else. So we have to stay on this road where we're actually participating in the mainstream development of that universal technology that's going to be used for everyone. The only thing I would offer as a caution, especially when we're talking about AI, I'm going to the M-Enabling conference next week, and I hear a lot of stuff that they're talking about and how they're going to use artificial intelligence. My fear is we're going to start implementing the use of artificial intelligence in places where we still need a human element. So I'm all about using AI to make sure that we are able to get better medical care for individuals, but I wouldn't want to remove the human component for caring for someone who's ill. All those different things. I wouldn't want to remove the human element that is really necessary, I think, for us to continue to coexist as a society. We have to have those opportunities in a strange way to be forced, right, to interact with one another if we're still going to get along.
Wonderful. Well, technology is developing, and it's wonderful to hear that blind people are being part of that development instead of being left behind. It was thanks to both of you. It was wonderful hosting you here. And I would like to thank both of you for coming to our event. And before we sign off, John Dennis, do you have any comments?
No, but I'm very, very thankful for everyone. Especially this topic is the important topic, and I'm excited about that. I'm excited. So, since my childhood, I want to drive a car, and if I have opportunity to try that, I'm very happy.
Thank you very much, everyone. I think it's 9:30 or so in Turkey. It's 2:30 in the US. A good day to everyone in the US and a good night to everyone in Turkey. I believe that's the end. Thank you very much.
Good afternoon, us.
Thank you. Thank you for having us.
Thank you.
Thank you. See you again.
See you. Thank you. Take
And
care.
Faruk, Faruk,
You're
thank
welcome.
you.
Bye.
Again.
Thank you. Bye.
Goodbye.
Thank you very much.
And this is the, yes. I can stop the transportation. First off, we can